Hello and welcome, I'm Sammy K. Powers, and in this video we are going to be finding a bug in the PHP source code, and we're going to be trying to patch it. Now you must take this video with a grain of salt, because as far as internals contributors are concerned, I'm quite a newbie, and I don't know really what I'm doing. So I want to just show you my process in going from finding a bug to submitting a patch. So where do we begin? We need a bug, something that hasn't been patched yet. And I actually found a bug on an accident. I was browsing the Gcov website, which shows the line coverage for the C files, and I was just browsing the JSON extension, wherever that is. There it is. And I was looking under JSON_encoder.c, and I was just kind of looking for those red lines that need to be covered by tests. And I was scrolling through, and I found this one. Failed calling JSON serialize. This is sort of this error case that hasn't been covered yet. And I was doing this for the Chicago PHP user group because we were participating in PHP Test Fest 2017. So my first task was to figure out how we could hit this line from a PHP script. So what I found was that this was being called from within the context of JSON encode. And if I just go to php.net/JSON_encode, it's the documentation for that if you've never used it before. But you basically send it in a value. It could be any kind of PHP variable. And it's going to return a string, which is basically that value encoded into JSON. So how does this work? Well, let's pop over into Atom, and I'm going to create a new file. We're going to just save this in the root of the PHP source folder. So we're going to call it JSON encode.php. And we are going to open up a PHP tag. And I'm just going to show you how this works with objects, because that's where this is going to be important. So class foo doesn't have to be anything new foo. So an instance of the foo class, which is completely empty. Now I'm going to save that and pop over to my CLI, php -- version. I compiled a version of PHP from the master branch, which gives me PHP 7.3 at the time of recording. And we're going to just run this file we just created. And as you can see, it returns a string, empty object, JSON notation. I'm going to go back to this and say I have a property, public property. And I go back and run the script again, and suddenly you can see we have an object with a property bar and a value of something. Say I set a private, and if I do a protected, let's check and see if protected works. It doesn't. It's only public properties that it's showing. So that's kind of how it works. But what if you wanted to, say, change what was being returned in this? Well, you could make use of JSON Serializable, which is hard to say, but it's an interface that has a method on it, and you can return specifically what you want JSON encode to encode. So let's create this, and I'm going to create a public method called JSON Serialize, and we're going to have it return, let's just have it return an array, 1, 2, 3, just like that. Function helps if I know how to PHP. All right, let's run this again. And that didn't work. Oh, you know what? Of course it didn't work because we didn't implement JSON Serializable. Implements JSON Serializable. Wow, that's a mouthful. Let's try it again. And now you can see it's returning test 1, 2, 3 instead of, what is it, bar something, right? So JSON serialize is being referenced here in the error message. Let's just try to break it. Let's just try to make JSON serialize do something that we wouldn't want to. Say for example, we just killed this. I'm going to kill this, all these members here. I'm just going to have it return nothing, right? So just nothing at all. So I'm going to go ahead and run that as is, and it just returns null, which is not exactly valid JSON, but whatever. So that didn't break it. Why don't we try to throw an exception, right? New exception. And this could be anything, but we're going to say, oops. And let's try that. Let's run it again. And fatal, uncaught exception, oops. Now that doesn't match the error we're looking for. If we go back and look at the Elcov website, we can see that it says failed calling %s JSON serialize. Our message doesn't look anything like that. So we're not hitting this line yet. Just to clean things up, I'm going to copy this out or cut this out and put it inside of a try catch. Let's run that again. And as you can see, that's the oops that we created, the oops error message. So the exception's being thrown, and it's being caught, and it's echoing out the message oops. So that's not breaking JSON serialize like we want. What can we do? Maybe instead of throwing an exception, why don't we try to return... Why don't we do return itself, in fact? Let's do that. Let's just return itself and see what happens. So we run it again, and it returns an empty object as we'd expect. But what if we returned a new instance of itself? So new self. We could just as easily do new foo, that would work, or we just do new self. I kind of prefer new self, so we don't have to rename it here and here if we need to change the name. Although if you have an IDE, it'll do it for you magically. We can also do new static. It's a little bit different, but we're going to stick to self for now, just for kicks and giggles. And let's run that. And segmentation fault. That's not a PHP error. That's a C error. In fact, if you ever see a segmentation fault, no matter how bad your PHP code is, that's a problem. That's a bug in PHP source. So hopefully you can replicate that error easily, just as we have done, and we'll be able to submit a bug and hopefully a patch for this. So what is going on? JSON encode reaches a segmentation fault when we try to return a new instance of itself from JSON serialize. But you know what? We should double check and make sure that this isn't just like something they're doing on the master branch that screwed something up. So why don't we take advantage of eval.org, spelled the elite hacksaw way. And I've already put it in here. All we've got here is we have our class foo. It implements the JSON serializable. We have public function JSON serialize, and it's returning a new version of itself. We're var dumping it, JSON encode this instance of foo. And as you can see, from PHP 5.6 all the way to the release candidate 2 of PHP 2, which is the latest and greatest as the time of recording, you can see process exited with code 139. We do not have a PHP error. You probably won't think it's pretty, but we do need to see some sort of error from PHP here. So now that we've confirmed that this bug happens across all versions of PHP, or all actively supported versions of PHP, we need to submit a bug report, and that's what we're going to do now. So here I am at bugs.php.net, which is the official place where bugs are tracked. It's the bug tracking system for PHP source. And there is a place here to report a bug. So we're going to click on that. And there's this form you can fill out to enter details about the bug, and it's going to create a ticket for it. At the top here, it's going to ask for your email address and a password. I already have an account here, so I'm going to go ahead and just log in under my account before I submit this bug. And all right, now I'm logged in as my username, Sammy K, and I'm going to fill out this form through the magic of editing. It's going to go real quick. All right, so for PHP version, I chose irrelevant because it affects them all. And package affected, it said JSON related. It took me a while to actually find this. It's under data exchange functions. There's not like an extensions where you just do ext/JSON, but I just selected that. It is a bug, not a feature or a documentation bug. I just put my operating system that I'm running on, which is Mac OS. And I have a little title for it, JSON serialize, returning new instance of self causes seg fault. And then here, typically you want to add a lot more information, especially if you don't know how to patch the bug yourself. In this case, we're pretty confident that we're going to be able to patch this bug. So I'm going to kind of not put all this stuff it's requesting here, but I'm going to explain the bug a little bit. You can easily create a seg fault in JSON serialize by returning a new instance of self. You can see this affects all actively supported versions of PHP here, and I put a link to the eval that we created just a second ago. I'm working on a patch, and we'll be submitting it as a PR soon, as a pull request. And I put that in there just so that someone doesn't just go in there and just fix it real quick, because some of these internals contributors have fast fingers and they can just fix it real quick, but we want to patch it. We want to be the ones that patch it. Test script just to show how to reproduce the bug, and with just a few lines of code, we can make PHP seg fault, which is kind of exciting. We don't have a patch yet, so we don't need to worry about these things, but the expected result is that we should see a fatal error or at least an exception being thrown. And the actual result is a segmentation fault, which should never happen in PHP. So let's submit the bug report. Fingers crossed. It is asking us to make sure that we've checked that this bug isn't already on there. And this one looks similar. It's seg fault with throwing JSON serializable. So we should check that just to make sure. And if we scroll down, we can see their code, the test script. It's when they throw a new exception, they were getting a seg fault there, but that's been already patched. So this is completely unrelated. So we actually have a different way of making JSON serializable seg fault. And we can just go through each one of these just to make sure that we're not submitting a duplicate bug. We're going to go all the way back down to the bottom and submit the bug report again. We have been given a number for our bug, 75237. That's going to be a number we want to remember because we're going to be using it to reference lots of things like the branch name, the test file that we create. It's going to be showing up in a number of different places. But now we have a bug. Woohoo! The whole world can see it. Now let's fix it. Let's fix the bug and patch it. So how do we fix this bug? We had a segmentation fault, which is like the most useless error on the planet. C is not very forgiving when it comes to error messages, and you really have to go in and just step debug line by line to figure out where this thing is screwing up. So first things first, let us get the latest and greatest version of PHP just to make sure we're running on the latest version. So I'm going to do get fetch upstream. And upstream is the remote that I have set up that points to the original repo of the PHP source code. It's not my fork of it, it's the original one. So if I do get remote dash v for verbose, you can see here that upstream is pointed to the PHP/PHP source repo, whereas my fork is origin set to sammy_k/php-source. So now that we have all of the upstream changes pulled in, we can actually rebase our master branch based on that. So I'm going to do get rebase upstream/master into our master branch. Yay. Now our master branch is out of sync with the origin that is on GitHub, so you don't have to do this, but I like to keep things tidy by doing git push origin master. Now our master branch will be up to date on GitHub. So now that we have all the latest commits from the PHP source, let's compile PHP from source. And if you have never done this before, I actually have a video compiling PHP for source specifically in order to start adding tests later. But it just takes you from start to finish how you compile PHP from source. So I'm not going to get into too many details, but I do have this handy script that I like to use that I keep outside of the PHP source folder called config. It's just a bash script, so I'm going to show it to you. Basically what it does is it does a make this clean to clean out all the compiled binaries that it's done so far, VCS clean to basically delete anything that the version control is ignoring, and then it does build conf to build the config script, and then it runs configure with all these options that I kind of like to have by default, like thread safety enable, debug, the CLI. So I'd just like to do that. I keep it in there so that I can play around with things and I don't have to worry about having to remember these flags and stuff. Of course, there's also a config.nice that gets generated. But when you run VCS clean, it gets deleted, so I like to have a config script outside of the PHP source code folder that I can run every time. So let's go ahead and run that config script that will delete all the existing compiled binaries and config everything for us. Hopefully that didn't take too terribly long for you, but after it's done, we should be able to run make. So I'm going to clear the screen. I'm going to do make, and I'm going to do -j for jobs, and then the number of cores +1. I have 8 cores, so I'm going to do -9. And hopefully you won't get any errors, and hopefully you'll have now a compiled binary that you can use. The compiled binary will live at sapi/cli/php, and we can do -- version to see that we have the latest and greatest build. Now, if I do git branch, I'm on the master branch at the moment right here, as you can see. So if you remember, our bug number was 75237, so I'm going to copy that. And that's what I'm going to create the branch name with. So I'm going to do git checkout -b for our new branch, and I'm just going to call it bug 75237. And now we should be switched to the bug branch that is branched off of the master branch. And I just branched it off of master because it affects all versions of PHP, and whoever the release managers are for each of the versions can pull this bug into their own branches for a bug fix. So let's go ahead and make sure that this thing still breaks with our new version of PHP that we just compiled, and sure enough it does. Segmentation fault, no good. So how do we go about debugging this? Well, we need a debugger. GDB is the debugger of choice for us, and it's going to help us step through the C code and figure out what's going on. Now, GDB isn't set up to run PHP files, but we can make it run the PHP file, or at least see what it's doing behind the scenes by doing this, gdb --args, and then pasting in this command right here that we sent. So we want to send it the compiled binary, which is compiled from C, and the argument is, of course, our PHP file. So if we run this, GDB will happily pull that in as a program. Now, we need to first set up a breakpoint, and we don't really know where to stop, really, I guess. So we do know that this is related to JSON encode. We know that the error is happening somewhere around here in the PHP, but where is that happening in the C? Well, there is a macro called php_function, and it says here starts a function. So why don't we start there? I'm going to copy JSON encode here, and I'm just going to go to the PHP source code at github.com/php/php-source. And I'm going to search for php_function and look for JSON encode. And as you can see here in the JSON.c under ext/JSON/JSON.c, we have the definition of JSON encode starting at 228. So I'm going to set a breakpoint at 228 of ext/JSON/JSON.c. And the way you do that is you type break and then the name of the file, colon, wasn't it 228, I believe. There we go. Now we have a breakpoint set at that exact location. So now if we type run to run the program, we should see that it hit a breakpoint and stopped. Great. So now we're running our program. It stopped at a breakpoint. It's not giving us too much information here. We just see this one little line. So if you type list, you can get a little bit more context of what's going on here. Okay, here we go. 228, that's the line that we told it to stop on, and it ended up stopping, further on down. That's cool. So it's executed these couple lines so far. What we could do is just start stepping through the program and see where it takes us. So we'll type in for next. So we'll just keep going through the lines here. JSON. Let's dive into that. Oh, wait. Segmentation fault. Okay, so now we're getting a little closer. PHP JSON encode eval. Okay. We know what happens into there. So instead of typing next, which jumps over, we need to probably step into by typing S for step into. So the program stopped running, so we need to run it again. But before that, let's set a breakpoint at PHP JSON encode eval. So now we have 2 breakpoints set up. So we need to rerun the program. It's going to ask us to start from the beginning. Sure, we want to run it from the beginning. Here it stops at the next place. I'm going to press C for continue to the next breakpoint, which was the one that we set up here. There we go. I'm going to type list to give us more context. And here we go. We're inside of PHP JSON encode eval, and we're in this giant switch statement. I'm going to go next. Next. So it's okay. So it jumped into the JSON encode serializable object function right here. Okay, cool. I'm going to copy that just in case we want to set it up as a breakpoint. Click next and list for some context here. We're inside of, we're back inside of PHP JSON encode eval. Okay, that's interesting. Next. Next. I'm going to actually press enter and you'll remember next. Next. We hit the breakpoint again and again and again and again and again and again. I just hold enter. Look at this. We keep hitting it over and over. What the crap is going on? Well, it looks like we're in infinite loop. Specifically infinite recursion, which is basically creating new values and stacking them on top of each other. And there's a new instance that gets created in a new stack, a new frame in the stack. And it keeps stacking on top of each other and on top of each other. And eventually it just runs out of memory and we hit a segmentation fault. So now that we know where this infinite recursion is happening, why don't we try to see if we can write a little patch for it? So I'm going to pop over into JSON_encoder.c and look for that function that we just ran into, PHP JSON encode serializable object, and there it is. So let's take a look at this. I did a little homework just to make sure that I was at least somewhat sane when I was talking about what this thing is doing. But again, I'm take all this with a grain of salt because I don't know 100% what's going on behind the scenes. But if we look at the parameters or the arguments that are being sent in here, we have a smart string, which is a special API for managing strings, and it's called buff, which isn't very descriptive. It has to do with when you have one of those options set, like PHP JSON partial output on error. If that's enabled, then you get like this kind of encoded value in return when an error happens, but we don't have to really worry about that. It's not really important. Val, though, is important because that is the value that is being sent into JSON encode. If we look at the original PHP script, it is this value here. It is the instance of foo. So that's what val is. It's a zval. Here we have options, and if we pull up a JSON encode at php.net, you can see that this is what that relates to. It's the bit mask of all the options that you want to send in with the JSON constants. And finally, we have the encoder, the internals representation of the JSON encoder. So here we initialize a few variables at the top here. First, we examine this instance of foo that we're sending into JSON encode, and we're grabbing something called the Zen class entry off of that. In the fantastic phpinternalsbook.com, there is a chapter on zvals, and if we look at the basic structure of a zval, we can see that it has a member called ZenClassEntry, and it is referenced by the name CE. And that is a variable that exists on a Zen value. And that's basically what we're pulling out of the zeval right here with this macro. Now I think what this next line is doing is pulling the properties off of val and putting them into a hash table. I'm not exactly sure how that works behind the scenes, but it's not super important for our purposes. Then we initialize two zvals, retval, which is the return value from JSON Serialize. If we go back to our PHP script, we can see JSON Serialize, this return value, whatever is returned here, it could be a string, it could be an array, whatever it is, that value is going to be retval. So right now we're going to have a new instance of foo. We also have this f name, and you're like, first name, what does that have to do with encoding? No, it's function name, and we're going to see it being set a little bit further down. And we also have return code, which isn't super relevant for what we're trying to do. So we do a little bit of error checking here, and if it fails, it returns a failure. And here's where we set f name that we saw earlier, and we set it to JSON Serialize, which is the name of the method that it's going to try to invoke. So in the internal side of things, if I wanted to invoke a userland method like JSON Serialize, I would do it with call user function x, like in this example here. So the parameters on this, the first one is the function tables that exist in the executor globals. That's what the EG stands for. I'm not really sure why that's actually being sent in here, because what we actually are trying to invoke is a method on an object. The object is val, which is our instance that we send into JSON encode, and on that object we want to call the f name or the function name or method name JSON Serialize, which we set above here. And we want to put that value into retval. Notice how we're actually passing these in as by reference. And so their values are going to get set within this function, and then suddenly when we're back into the scope of this function, the value will have changed to whatever they set it in this function. This is typically not how we do PHP, at least we shouldn't be doing PHP, the quote-unquote wrong way to do PHP, but this is the way they do it in C all the time, is they pass values by reference through the arguments, and they get changed and sent back. And if that fails, of course, it executes all this junk, throws an exception if things are wrong. So let's assume that passes. And in our case, it does pass. Then we ask the executor globals if there's been an exception thrown, and if there has, do some stuff and some things. But then we get down to the real meat of what we really want to look at here. We have a fork in the road. It checks for something, and it either goes into PHP JSON encode array, or it goes back up into PHP JSON encode zval. Well, if you remember when we were debugging, this is the parent function to what we're in right now, because once it hits the zval, it checks to see what type of value it is and sends it to the appropriate function, which in our case it was an object. So we got into the object, and then that returned an object, and an object, and an object. So we keep hitting this. For some reason we keep going to this fork, to zval. So we need to either send it to array or create something else, or I think what we actually need to do is return some sort of error. Because if with that infinite recursion happens, it needs to tell the userland people that, hey, this isn't good. We're blowing up the whole stack. So let's examine this if statement and figure out why it's hitting this fork in the road and not this fork in the road. Well, first of all, this first line, we're looking at the return value. So once again, if I look at the PHP, we're looking at the return value of JSON Serialize, which happens to be a new instance of self. So the return value is it's checking to see if it's an object. If the type, the Z type, this is a macro. You use macros all the time in PHP, and usually when you're handling zvals or pretty much anything in PHP, you wrap it with a macro. So if we want to look at the type, we want to look at the type of this particular zval. It's an object. So this, in our case, it's true. So yeah, because we returned an object. But we also want to check, and we're wrapping this with another macro. If this object, this instance, is equal to the value. Now, if you remember, value is the thing we sent into JSON encode. So if this instance is the same as this instance, so in the case of that, where we return the same instance, this branch gets executed, because this is true for both. Yes, it is an object, and it's the same instance of the thing we threw into JSON encode. So that's why that gets executed. However, in our case, we're not doing that. We're doing a new instance of self, so it's not the same instance. So this part is true, this part is false, so it moves on to the next branch, which sends it back to the top, and then it enters back into JSON object again, which goes back to the top and enter JSON object again and then back to the top, and that annoying thing. So we need to fix that. In the last few lines here, do some garbage collection and things like that, which we don't have to worry about for the right now. We will in a second though. So we need to create a condition that will recognize the specific recursion that we are getting and stop it and throw an error. So what we'll do, I don't know if this is the best place to put it, but I'll let Nikita Popov complain later that, hey, that's not where you're supposed to put that. So what kind of condition can we put here? Well, first of all, I think we can actually just copy paste this part right here because we want to see if the return value, the thing that JSON serializes is returning, is in fact an object. So that part we can keep. Now this next part though, when we were checking down here to see if it was the same instance of itself, that's got to change. In fact, we were looking for the opposite of that. We want it to not be the same instance of itself. So we want to make sure it is an object and not the same instance of itself so that we can handle this error condition. Now, how do we throw an exception in internals land? Well, there's one way to do it. I'm just going to copy paste it. It's up here. Here it is. Zen throw exception. I'm just going to copy paste this whole thing because I'm a PHP programmer and that's how I do. I copy paste. Here we go. Let's change the error message here. We can still keep this bit right here, the JSON serialized part. %s, if you're used to working with printf or sprintf or something like that, it's kind of the same concept here, where this value will replace the substitution character here. And in this case, we're just looking at the class entry and getting the name of the class. So we want to show the name of the class, scope resolution operator, which has a very, very long token name inside of PHP. It's kind of like a little Easter egg if you want to go Google that later. But then then the name of the method. So we want to have a useful error message here. So we want to say JSON serialize cannot return an instance. Oh, I should say a new instance of self. Okay, now that we've thrown an exception in internals land, that doesn't actually halt the script execution. Basically, this just sets some variables and says there's an exception being raised. Now, we need to actually exit out of this, and the way we can do that is by doing the way that all these other failures have been happening up here, and that is return failure. So I'm going to go down to the next line and return failure. That'll kick us out. One other thing, though, we're going to have to worry about is garbage collection. It's something we don't have to worry about in PHP user land, but back in the internals, we will have to worry about. So let's take our PHP script and run it through our patch and see if it works. So let's do make to compile our changes, and it built successfully. That's great. And we run it. Haha, and it looks like it worked. Check it out. Our brand new error message cannot return a new instance of self. We got the foo, that's the name of the class. This is working great, except we got a bunch of other junk here. What is this? 2 memory leaks detected. That's not good. As I mentioned before, we need to worry about garbage collection. And in fact, there are 2 variables that we missed. We created, if you look, this is kind of handy if you're kind of new to internals like I am. What I found very helpful is if you are in a context that is returning an error, see what else they're doing. They're doing a couple of different things. Like every time they return an error, they're doing this detour thing and this apply hash protection decrement. Because up here it got incremented. We need decrement before we return. See here it's happening again. So basically this eval pointer detour thing is basically it decrements the reference count until there's 0, and then it just unsets the variable basically. So I'm literally just going to copy paste these. And I guess I'll put them like right here. It doesn't really matter, I don't think. And then I definitely want to take this bit and put it here. And technically we could pull this bit in because if this option is being set, we want to return null as our encode value, as our serialized value instead of false or whatever the default is. But for now, I'm going to leave that out just so we don't have to get distracted. I'm sure there's other things that we should probably have to do here, but we'll let the people that are reviewing the PR make that call. So I'm going to make it again to get our new changes. Looks like the build was successful. Let's run it again. And there we go. Our bug patch has been successful. We are now officially bug patchers, except what about a scenario that we haven't thought of? Maybe you thought about it, but I hadn't thought about it until just now. Check it out. What happens if I do date time? So now I'm creating a new instance of an object, but it's not the same object as the main parent object that's being sent into JSON encode. What happens when we run this? I don't know. Let's check it out. Let's clear it. Oh, crap. Now we got a problem. JSON serialize cannot return a new instance of itself. It's not supposed to happen when you send it just any old object. It's supposed to happen only when you send it an instance of itself. So we have to go back to our if statement and figure out what went wrong. Well, we're seeing if it's an object, which datetime is, and then we're seeing if the instance is not the same as the instance that was sent in the JSON encode, which it's not. So we need another condition here that will check to see if the instance that is being returned is of the same class name as the instance that's being encoded. So essentially what we would do if we were using PHP terms, if we were to say like val class name. This isn't valid C or anything. I just wanted to show you what we are looking for from like a PHP perspective. We're looking for the return values class name compared to the values class name, and we want those to be the same. Because if they're the same and they're not the same instance here, but the same class name, then we know that we're going to go into infinite recursion. We're trying to fix that. So how do we do this? Well, we actually happen to have at the very top here a CE variable that got set, Zen class entry, CE, and then we pull the class entry information off of value. So we do know what at least this is. We know the name of this, so we can pull this off. And the way we do that, since we already have the Zen class entry has a name property on it. So if I go like this, if I go CE and then do name, that'll be the class name, the full class name of the value. So now how do we find that same thing for the return value? We don't have a CE that we can reference. Well, if we go back up to where CE is being set, we're using a macro called zObjectCEP, which doesn't really seem to make much sense, but it's grabbing the class entry off of value. And as you saw up here, the value is just a zval. Now, retval is also a zval, so we should be able to wrap this. But there's an important thing. This is being sent in by reference. And here, and inside this class, retval is not a pointer to somewhere else. It's actually the actual value. So we're going to have to change this macro a little bit. But we can still use this macro. So I'm actually going to copy this because we know it returns the CE. And go back down to where we've been working. And we can just replace this val class name PHP foo with the macro that grabs the CE. We don't want to pull it out of val because we already have that. That's what this is right here. We want retval right there, the return value. And return value, as I mentioned before, is not a pointer, so we need to remove this P so that we can grab the proper thing, and we're going to do name. Now, this looks like it might work, except for the fact that comparing strings, this is going to return to Zen string, which is not just like a normal string you can compare. So we actually have to use a special API in order to compare Zen strings. And this one actually has a legit name. It's called Zen string equals. And the first argument is the first thing you want to compare, and the second argument is the second thing you want to compare. So now we have a way of comparing the strings. If the class name of the value is the same as the class name of the return value, then we know we're in luck. So let's make this and hope that there's not any errors. Oh, got an error. Oh, and let's make sure we're actually doing and. So we're checking this condition and this condition and this condition. Okay. Okay, let's make it again. Oh, looks like it worked. So let's run the script again. And there we go. Awesome. We have a datetime instance being basically serialized into JSON. And let's make sure that this works. So if I return a new version of self, it will give us our new error. So let's clear this. And there we go. JSON serialize cannot return a new instance of self. So our patch worked. So we should totally submit a patch for this. But before we do, we should actually write a test to make sure that this actually fixes the thing that we were expecting it to fix. So how do we do that? Well, if you've never written tests for PHP, I highly recommend checking out my video series on writing tests for PHP internals. You can check that out by clicking this magical link here that is being displayed on your screen. So I'm not going to get into too many details about writing tests for PHP source, but we're going to do one real quick. Here we go. All right, so let's create a new test, and we're gonna put it under ext/json/test/bug, and then the bug ID that we got from bugs.php.net, which is 75237.phpt. I'm just gonna paste this in and save it real quick. Pull it up in Atom so it's a little prettier. So here's the test. Just as a convention, if you're writing a test for a bug, then you would just use this format bug, and then the ID of the bug, and then pasting in the title of the bug. I have a little skip if section here to make sure that the JSON extension is loaded, and otherwise it's not going to run the test. And the file section is where the PHP code goes, so we just basically pasted in the exact code that we've been using for everything to show that the bug exists for sure. And then there's an expect section that has the error message that we just created, because we're expecting this to throw an exception, and we're going to get the message from the exception and echo it out, which should be that. So let's run this test to make sure that it passes. So we're going to do make test tests equal 7.5. And it passes. Great. So it looks like we fixed the bug, but just to make sure we didn't break anything else, we should probably run all the tests under the JSON extension to make sure we didn't break anything inadvertently. All right, looks like we have a winner. 69 tests passed. One was skipped for whatever reason, but there were no failures. So apparently we didn't break anything. So it looks like we have a patch and a test to prove that the patch works. So we should submit it to PHP source. So I'm just going to do a get status, and you'll see we have a couple of files here. We have the patch here at JSON encoder.c. We have the test file that we just created, and we also have the JSON encode, which we don't want to commit. That was just the file we were just trying to play around with. So we're just going to stage these files by doing git add, and we're just going to do ext/json. And since the two files are in that folder, let's do that. And if we do git status again, status, you see now we have these two files that are staged and ready to be commit. So I'm going to go ahead and git commit -m for the message, and we're going to say fix bug number 75237. And there we go. So now we should be able to push this branch up to our fork, which we named the branch the same thing after our test file. If I do git branch, you can see we've checked out bug 75237. So I'm going to git push origin, and then the name of the branch we want to push, and it creates a new branch and it pushes it up to our fork. Now if I go back to the PHP source code on GitHub, the source repo, I can see that GitHub's like, hey, did you mean to submit a pull request? And I sure did. And let's do a quick check just to make sure that we submitted the things that we wanted to. We have our little patch here that throws an exception in the event that we try to return a new instance of itself. We do a little bit of garbage collection here, and then we return failure. Great. And we have our test here that passes. I think it's ready to be submitted. Now, if we go to the pull request for PHP source, you can see there's a couple of different bug fixes that are submitted, and they have the bug ID in the name and the title. So we can just keep that in there. I'm going to be a little bit more verbose here and just add the title of the bug. All right, so I add a little description here to make sure everything's good. This patch fixes bug, blah. I'm pretty sure the garbage collection is correct, but I just need to have a second set of eyes on it to make sure I didn't inadvertently break anything. Also, this just throws a generic exception. If you think we need to throw a specific exception, let me know when I can update the PR. So here we go. I think we're ready to push the button and launch into space. I like to add GIFs. I should have added a little GIF to that to, be funny or something. Oh, there's one more thing I forgot to mention. We have got to update our bug on bugs.php.net with the pull request that we just created. So I pulled up the bug again. I'm clicking on the edit tab here and scrolling down to pull request, add a pull request. And we're going to select this php-source repo. And it's going to load all the pull requests related to bugs. And if I scroll all the way down here, there we go. That's the one we just created. And that's our bug. And let's click save. And now you can see right here we have our pull request for this bug associated with this bug. But somebody from PHP source is going to review this and either say, this is broken and stupid, what were you thinking? Or or thanks for the bug and pull it in. I'm pretty sure they're going to get some feedback from Nikita or or Joe Watkins or somebody who will tell me something to change. They're probably going to be complaining about the fact that we're doing error checking here inside this same if statement. They might make me move it somewhere else, or restructure the if statement some other way, or maybe change the error message, or change the exception type that's being thrown, or something. There's always something, and I'm okay with that, because you know what? This is open source. You throw your code out there and you get it scrutinized and reviewed and critiqued, and it's just about the code. It's not anything personal, and you just become a better developer when that happens. So here we go. We're going to, with the magic of editing, fast forward to when they finally review it, which could be tomorrow, it could be in a few seconds, it could be next week, it could be next month. Who knows? But see you then. Welcome to the future. We're back, and I would like to start off by showing you this little tweet that Sarah MG from Internals tweeted not too long ago about bugs. Oh my, a bug. It seems to be stuck. Oh my god, what have I done? I think that's kind of the scenario we just ran into. Because if you look at the PR we submitted, you can see it is now closed, because although our little patch worked nicely, we got lots of feedback from a number of different people. But here's this fatal thing I never even thought about. You, while you were watching, probably saw this, but I didn't even catch it. But what happens if our instance of foo returns a new instance of bar, which returns an instance of foo, which returns an instance of bar, and it keeps going deeper and deeper in the stack, infinite recursion, but in a different way, and would bypass our check. So just to see how that works, let's go back to our original script here. We have the class foo, which implements JSON and serializable, and it creates a new instance of itself, and it goes into this infinite recursion and then ends up creating a seg fault. So if we run this, and I called it JSON encode 2, here's our new little fatal error that we created, which foo cannot return an instance of itself. So if we go back to the PHP script, I'm going to basically replace this code with the example from GitHub, that it's got an instance of foo, which returns an instance of bar, which returns an instance of foo, and back and forth. And let's see if this bypasses our patch. So let's try it again. Segmentation fault. So we didn't, in fact, fix this bug. Now, we probably could do something that would ultimately fix this and realize there's infinite recursion, but if we go back to the PR, we get a lot of feedback from a lot of different people. It goes kind of back and forth quite a bit. And we talk about that there's actually a deeper problem here. We did get a little bit of cold review here, which is really cool. So they were saying like, hey, are you sure you're doing this right? It looks like you're doing something else but you meant to do this. And I was like, yeah, that's what I meant. So this is really cool. We got a code review. And on top of that, we were realizing that we got even a deeper problem. And finally, Nikita Pavlov, who I knew was going to chime in, but eventually did, and said, if someone was to take a shot at fixing the root of the problem, my suggestion would be to look at stack guard pages, and we may be able to catch segmentation faults caused by a stack overflow and display new user-friendly error message. So basically what's happening is a stack overflow problem in PHP basically inherently causes segmentation faults no matter what. In fact, if I go to the official bug that I had posted, that has since been closed by none other than Nikita Pavlov, and he's marking it as a duplicate because there's another issue that is open that has to do with __ clone, the magic method, but it's having the same recursion issue that's causing a segmentation fault. It's a global issue, not related to just JSON Serializable, but to a lot of different places in PHP. Interestingly enough, though, if I were to change some of this code, there are guards for infinite recursions. For example, if I were to have a function foo, and I returned, or if I just actually not even return, if I just call foo from within itself, we're gonna hit infinite recursion. So why don't I just call foo from out here? Why don't we try running that? I just turned JSON _encode 2 to do that. So we should see a segmentation fault, but instead we see a fatal error. So some of this Stack Overflow stuff has specific error cases for them to show a user-friendly error in userland, but there's a lot of places where you run into segmentation faults with a Stack Overflow in PHP. So the root of the problem hasn't been fixed. I have no idea how I would go about fixing that. That seems like a much bigger task than I'm willing to take on at the moment, and there's a couple of other people who seem to be working on it at the moment who actually know what they're doing, so I'll leave that up to them. But all in all, I think this was a successful endeavor because not only did we learn a lot in this process, but it also brought to attention to a lot of the core developers that, hey, there's this problem that other people are having with the Stack Overflow problem. It keeps the conversation going, and the squeakier the wheel, the more attention it's going to get and the more oil it's going to get potentially. So I think this might be a problem that gets fixed pretty soon, hopefully. With enough squeaky wheels, I think they're gonna have to touch it at some point. I think I'm just going to close on this beautiful comic strip by Sarah MG to just sort of fully take in what it feels like to start debugging and finding bugs and actually trying to fix things in our software projects, because this is pretty much what I run into most of the time when it comes to bugs. And I hope that you've enjoyed this journey with me and are able to find bugs and are willing to go down the rabbit hole and see if you can try and make a patch, and maybe it'll end up the way we did today, and we find some deeper bug that looks like a monster. Or maybe it'll be a simple patch that ends up getting merged into PHP source. But I wish you good luck in the endeavor to fix bugs in PHP. Until next time, I'm Sammy K. Powers. See you later.